We have been talking about general introduction of environmental geomechanics, and I have given you a lot of logics until now about the scope, the philosophy, what are the issues which environmental geomechanics specialists or environmental geotechnologists are facing in contemporary world, and in particular how to deal with these situations. So, if I sum it up, whatever I have discussed until now, the environmental geomechanics is a branch of engineering and technology, where mainly we study the quality of water and land resources, because these are the basics or basic requirements for the sustenance of the life. We always try to find out an optimal solution between the different constraints which I have discussed in the previous lectures. And another activity in which environmental geotechnologies are involved is the transport, use and disposal of hazardous waste, and then treatment of the waste water and water. Earlier it used to be a domain of environmental scientists, but now I hope you will realize that with the recent developments and technologies which are being implemented, the role of environmental geotechnologists becomes very important, and of course, the reuse of water. We also talk about the investigations or the analysis, design of foundation systems, seepage control, earthen dams, water resource structures, and we are quite interested in studying what is the response of the foundations and embankments to environmental activities. And these environmental activities can be grouped in two categories. The first one is man-made and another one is the natural process or natural calamities we call it. So, here I have given you some examples of what are the man-made activities, though we discussed quite in details. Primarily the man-made activities would be industrialization and population explosion, and once you talk about these issues, everything is a part and parcel of this, including the scarcity of the land which I talked about in the previous lecture. The second issue is the natural environmental activities, and I hope all of you are now seeing that all of us are facing in a big way the disasters which are occurring naturally or which could be man-made also. So, this is what the point of discussion is, what causes what. Ultimately the humanity and the society is suffering, and we have to try to come out of this situation. So, when we talk about the natural activities which are responsible to motivate us, all right, to become an environmental geotechnologist and take up these type of assignments, would be primarily earthquakes. Anything which comes to your mind apart from earthquakes? See, hurricanes, tsunamis are playing a very important role. I have been dealing with several examples in our own country where post tsunami the rehabilitation part, particularly in Andaman and Nicobar area, became a very big challenge. Just to give you a very quick example, tsunami brings a lot of sediments along with it, and these sediments get deposited on the coastline, and now the infrastructure on these type of loose unconsolidated sediments is going to be a very big question mark. So, something of this sort is being done in the coastal areas of the country. Hence, tsunami has become a very important thing to be studied, though I will not be discussing much about tsunami in this course, because I am not an expert in this subject. The another thing could be cloud burst, alright, it is a natural disaster. So, I hope you understand what is meant by cloud burst. All of a sudden a tremendous amount of rainfall taking place in a limited time, alright. Mostly this happens in the hilly terrains, upper reaches of the Himalayas or the hills, but nowadays it is becoming very common in cities also, alright. This could be the change in the climatic pattern. So, in what way the cloud burst could be linked with the practice of environmental geomechanics is the height of imagination. I hope you can make it out very easily. When cloud burst occurs, the chances of landslides become extremely severe. and landslide is a subject which every geotechnical engineer would like to handle. So, this is how things become interdisciplinary and they get linked with each other. So, hurricanes, tsunamis, design of foundations for extremely high wind velocities. So, until now you have been very conveniently designing the foundations for insignificant loads, I would say insignificant moments. But recently you must have seen when the eastern part of the country was hit by cyclone. What is the name of the cyclone? Feni, alright, very similar. So, what type of disaster occurred and how to mitigate this? That means you have to revise the concepts of conventional geomechanics, where the moments for conventional buildings are not taken into account much. So, this is how the subject is getting evolved. The moments are becoming more and more important on the foundation system rather than the dead loads. Volcanic eruptions. We are lucky that we are in a country where not many volcanic eruptions have been seen yet, except for the islands of the country, particularly Andamans and all. But think of the countries or the civilizations which are on active volcanic regions. So, this is going to become a very big problem. One good example which you can Google would be how these Japanese train the lava so that it does not influence the rehabilitation. So, they channelize the entire lava and they are experts in this. So, there are very good YouTube videos which are available on this. So, the volcanic eruption could cause significant problems as far as the human settlements are concerned. What else could happen because of the volcanic eruption? This I was talking about the molten state of the lava which is flowing like fluid. So, few years back you must have heard about volcanic eruption which happened in Europe, and because of that the east got disconnected completely with west. Why? No idea. Check it out what happened. So, when you have eruptions of particulate matter in the environment, the visibility and the density of air changes, you can't fly through. So, for several months the flights remain unoperational. Ultimately what happens? It influences the economy of the nations. So, suppose if you are totally disconnected from rest of the part of the world, you are going to be severely affected. So, these are the future domains of environmental geomechanics, I am very sure, which you guys must be facing, I would say. So, the right time to gear up and adopt them as the future profession for geotechnical engineers. Do not get limited to what you have been doing very conveniently, because that part people have already mastered. So, I hope you have understood there is a series of natural disasters, alright, and these are mostly man made, they could be natural also. Avalanche, I think we have talked about, movement of the snow on the hills. So, this is also a good example of how natural activities might create chaos, particularly in the upper reaches of Himalayas. If you Google it, you will find a lot of information on how avalanche influences the structures. Instability of the structure is caused by movement of the avalanche. Okay. So, unfortunately, we do not offer a course of cold region geomechanics in India, because we have ignored certain parts of the country. We never thought that they are the part of the mainstream, it looks like. But I am sure one of you or some of you should really take up these challenges and try to consider the geomechanics of frozen soils. So, fortunately in our group, R&D group, some of them are working in this area, and we are trying to see what is the response of the soils when they are subjected to varied environmental conditions. Alright, anything which comes to your mind apart from this? Floods, cloudbursts, floods, yes, flooding also is a part of the mostly man made nowadays, rather than you must be reading in newspapers every day what is going on and who is responsible. There is a big debate which is going on. So, be a part of the central theme of discussion of the country, you cannot be isolated. Yes.
The enormous snowfall is all can be.
Yeah, so it will result in avalanche. So, the way you talked about NCOC materials, normally consolidated, over consolidated soils, avalanche is nothing but a over consolidated snow. So, imagine the layers of snow getting deposited and the next deposition coming over, hitting the particles and the system becoming more and more condensed is what avalanche is, alright, fine. So, snow mechanics and mechanics of the frozen regions is becoming a part of today's discussion. I will talk about this in details. Anything else apart from this? What are the recent trends which we might or might not cover in the realm of environmental geomechanics, but my idea is to keep you updated on what is happening internationally, and this is what the present day scenario is in geotechnical engineering, which I do not know whether you are aware or not. So, the list is very long, but what I have done is I have tried to stuff everything in few sentences and just to give you an idea about what is happening in contemporary world and what geotechnical engineers are doing. Sky is the limit. So, we start with the material science. The present day geotechnical engineering is mostly about the materials, and these materials could be neo materials. Neo are the ones which are new, which are not conventionally existing, man made, alright. So, fly ash, silica fume, slags, different type of industrial waste which you are dumping are all becoming neo materials, because I think we discussed in the previous lecture that these materials require a very different and special attention of geotechnical engineers. We are also talking about the nanomaterials, different type of resins, zeolites, alright, different type of synthesized materials. And this is where, if you remember, when I was talking about the introduction of the course, I was saying that we talk about the interaction of geomaterials with environment, with a view that we would like to understand how the geomaterial is altering, and this alteration could be physical, chemical, mineralogical, biological, and so on. So, this has become a order of the day where people try to understand what type of alterations the material undergo when the interaction starts. And I think I have described interaction enough in the previous lecture, how the geomaterial, contaminant or environment interaction occurs. So, the perception is going to the basics of the materials, where we want to understand rocks, soils, groundwater, man-made materials as the basic materials, and then we want to understand the mechanics of these materials, alright. So, with this in view, the characterization becomes very, very important. I will be talking a lot about the characterization of geomaterials in the subsequent lectures. Mining and mineral engineering has become a part of geotechnical engineering. So, a lot of mining activities are being planned, executed by the geotechnical engineers, and there are some people who are working in the areas like geo-environmental issues related to mining. There are a lot of scope of understanding the materials, how do they react and how I can use different types of materials to support the mining activities. I hope you can realize slope stability anybody can do. So, when they come to a specialized surgeon, then the problem has to be different, alright. This is a quick answer. So, it is not only the slope stability, but there are a lot of other issues. Geohazard mitigation, I cited several examples of geohazard. Anything which is related to geo, earth is an hazard these days. I mean, we have discussed so many cases. There is a big boom in the information technology and artificial intelligence and expert systems in the realm of geotechnical engineering. How many of you are aware of this? There are a lot of expert systems. Abacus is a simple mathematical formulation, nothing else. Check it out on net. Soil Vision is the name of the company, and their products are expert systems products. Geo Vision, Soil Vision, sorry, SOIL, Soil VISION, Soil Vision, alright. And this was established by Professor D.G. Friedland and his son Murray Friedland in US, in Canada. Soil Vision. Vision, VISION, SOIL, Soil VISION, Vision. So, this is a system which contains several modules, and the question which you are asking about the mining, if you get time, students versions are available online. I mean, you can have trials, you can have tutorials, you can read a lot about it, and this is going to be a game changer for you guys. The commercial versions are quite expensive, but as far as your stage is concerned at this moment, you can start with the tutorials which are available on the Soil Vision, and you can read about what is happening. Just to add quickly what these IT and AI does, I mean, gone are the days when I would like to do hundreds and thousands of the samples they test in the laboratory. We do not have time. Look at the infrastructure, the way it is growing. So, how many labs in the country or in the world can really uh, you know uh, facilitate this type of testing? Not many. So, what is happening in today's world is people are working on speculative modeling, and that is what Soil Vision does. So, if I know few properties of the soils, let us say texture, particle size and some fundamental basic properties like specific gravity, I can speculate all other properties, shear strength, compressibility, heat migration, contaminant transport, everything. So, this is what is known as speculative modeling in geotechnical engineering, where a lot of IT and AI is being involved. There are people who are working in neural networks, ANN, I am sure you must have heard about artificial neural network. So, there are a lot of people who are trying to train the soil properties by using ANN networks, the way your mind works, neurons in the mind. Similarly, they are training mathematical models by which if you give some information, you can retrieve the information. So, some of you must have studied about SQL, that is sequential query language, is it not? So, sequential query language is the one which is quite useful for geotechnical engineers, and this is where our profession interfaces with computer science guys. So, the guys who are testing soils, they have a big data set of say about 7,000-8,000 soils, and if I ask a question, my soil with these 3 attributes, how it would exhibit the engineering properties, alright, roughly. So, this is what the speculative modeling is, query based language, and in a sequence you can ask the question to retrieve the answer. Is this fine? SQL. So, those of you who are interested should read about SQL, and this was going to be a good profession. So, expert systems are becoming very useful. Structural people, they used to use expert systems quite a lot for designing their bridges, alright. So, but now geotechnical engineers are not much behind, they are also using quite a lot. This is something very recent, Geo Interface, which deals with the molecular mechanics, and I do not know how many of you would be having the taste of all these things, but many times this is forced and many times it becomes a part of your personality to pick up something new and work on it. So, in our group we are doing a lot of Geo Interface. We have done fundamental studies of how soils react to a microbial attack, and the whole PhD is done to quantify this process, to understand what type of alterations system undergo when the bacterial activities or microbial activities attack the geomaterials, alright. This process happens in nature, and it is so sad that very conveniently geotechnical engineering people have forgotten about this. So, normally what we do is we bring the samples from the field, we put them in the oven and we create a different type of soil which never exists in the field, and this is one of the reasons which we were discussing, that why the systems are failing, because we are not doing the real life modeling of the material, we are not talking about the real properties of the material, these are the altered state of the material. So, most of the tests which you do in conventional geomechanics, you have very conveniently saturated the material, clear, to get rid of the third phase which is air, and that is the one which gives the most notorious characteristics to the system which has to be dealt with. So, Geo Interface is the one which is quite recent. If you get time, you can go through it and you will find that this is something which is going to be a game changer. That all your conventional theories are going to get changed once you talk about the presence of microbes in the geomaterial, and this is where molecular mechanics becomes very, very important to be studied by geotechnologists. Fire protection engineering, where do you think that this can be applied in geotechnical engineering? Any idea? Do you remember what is 2611? This is one good example of how fire protection engineering can be included in geotechnical engineering. There are ample examples. Another example would be, let us say you are designing the foundations for foundries. You know what are foundries? Metal processing units. You are designing hammers, or just say what do we call them as punching units, where something falls on a system. Another good example would be, let us say missile launching pads, rocket launching pads. A lot of temperature gets generated, and if the soils are not worthy of sustaining this high temperature, your simple shear strength theories are not going to help you in designing the foundations. So, these are the issues. Another interesting thing would be, those of you who are very eager to know what are the other scopes of fire in geotechnical engineering. Forest fire, which is a recent topic, is it not? Every country is facing this problem. So, what happens when the fire spreads in the let us say forest? What is going to happen? The vegetation gets burnt, and because of that the properties of soils also get changed. So, again you have created something which is not naturally existing. Now, this fire could be man made, or this could be natural, clear? But the whole idea is, what is the end effect of this? The end effect of the forest fire is it changes the fundamental properties of the deposits, and then the rains come, the chances are the erosions are going to be maximum from these type of deposits, clear? So, loss of vegetation, loss of organic matter from the soil because of the fire is becoming a very important topic to study these days. So, infrastructure engineering, creation of land, I think I discussed this in the class. So, when you do reclamation, dredging and reclamation is something which is now catching attention of people. Rheology of soils. And why rheology of the soils? Because when you do dredging and land reclamation, you dig out the soil from the sea or the water bodies, and then you spray it to recast it, all right, to resettle them. There are several examples in today's contemporary geopolitical situation. What is geopolitical situation? Understand what is happening in the South China Sea, what India is doing in the southern part of the nation, in the islands, all right. So, most of the countries are very active, and this has become an interesting subject, where land creation has become a very big issue. Very recently, I do not know whether you are aware or not, India opened up a new container terminal which is almost in the middle of the sea, this in Bombay, 4th container terminal. So, check it out on net, you just see the Google map and check it every year. If you see the Google pictures, you can realize what is the new addition, and that is the best way to learn how much active the geological boundaries these days are. I will talk about these issues, and the prevention and preservation and restoration of monuments and old structures, and rehabilitation also. So, wherever the minerals are involved, wherever the structures made up of soil, in the soil, with the soil are involved, you remember geotechnical engineers have to be there. So, most of the issues which archaeological society of any country faces would be restoration and preservation of the monuments, is it not? So, how would you preserve the foundations of old buildings? How do you let them remain the way they are? They should not deteriorate over a period of time. We do not want to lose the history and heritage of the country, is this correct? So, the big branch of professionals who are into these type of subjects. And fortunately, I also got enough opportunities to work for some of the ancient caves in the country, where it was a R&D cum research project for us. This is something very interesting. I was talking about the Arctic and the cold region geomechanics, and people have already started working on lunar and Martian geomechanics. Are you aware of this? Check it on net, there are so many papers. In fact, in our lab also we have published a paper on, I do not know whether you have seen this or not, this is there is a big crater in Buldhana district of Bombay, of Maharashtra, sorry. And this is where the meteorite fell long back, millions of years back, and then we were trying to study how the soils got created, what are the peculiar properties. So, the time has come when people are talking about extraterrestrial geomechanics. This is another interesting branch of geotechnical engineering, where a lot of work is being done, forensic engineering, where the legal issues associated with the problems I have been talking about are being dealt with, failures, post failures, dams are failing, floods are everywhere, the type of property damage, and roads are getting washed out. So, who is going to pay for this? These projects are insured. Insurance companies, they do not want to shell out the money so easily. So, what do? They appoint people like us. So, evaluate the entire project and give us a correct picture. They call it as a root cause analysis. What is the root cause of the problem? Clear? Was the structure not designed for the floods, excessive rains, landslides, and so on? So, this is also a very interesting area in which I think some of you should take a lead. Not many guys are present in the country, at least I would say, who are experts in the forensic engineering, and what basically it deals with is the engineering aspects of legal problems associated with the project mostly. I hope you are aware of DPRs, detailed project reports. So, if you check it on net, what is the problem with DPR, and you will get a lot of answers. So, you guys are blessed, everything is available on the net. So, you just check out what is DPR, what are the implications, how the projects are suffering, you will get plethora of information, alright. And last but not the least is energy. Some of you are quite fascinated with gas hydrates. So, I am going to discuss a lot about energy geotechniques, what energy, why energy is becoming a recent trend in geotechnical engineering, what it has to do with the geotechnical engineering practices. So, how does this list look like? How many of you are aware of how much about these subjects? Yes.
Forensic engine.
Forensic, good. Why?
If we know how the problems are caused, we can in the future we can see that if you do like this is going to happen. So
very nice, I am so happy. And then you should become an expert. So, you should read the laws of the land first, and then try to assimilate this with the practice of geotechnical engineering and try to find out the loopholes. Suppose if I construct a structure today and tomorrow it settles, who should be blamed? There are so many cases, I am sure you must be coming across. Times of India, National Network reports a lot of issues like this. Roads have been done and tomorrow road caves in. Who is responsible? Good. Mitra.
Maybe artificial intelligence and experts.
Why?
The data that I give it, we can actually speculate the models and.
Yeah, a lot of work is being done in this area, as I said, predictive modelings. I will be using these concepts quite a lot in practice of modern day geotechnical engineering.